Hello everyone, so the question we have is a hydrocarbon contains 10.5 gram of carbon per gram of hydrogen, 1 liter of vapor of hydrocarbon at 127 degrees Celsius and 1 atm pressure. It weighs 2.8 gram. Find the molecular formula of hydrocarbon. Right. So let us see. Now, to answer this, firstly let us discuss the meaning of the formula mass of a compound. We define formula weight or formula mass of a molecule or a compound as the sum of atomic weights of atom in its empirical formula. Right. We express the formula mass in terms of atomic mass unit. And to find the formula mass of hydrocarbon, we need to find first of all the formula of hydrocarbon. Let us assume that hydrocarbon is CX and HY, right? And we know that ideal gas equation, that is PV equals to nRT, right? So we can replace the number of moles Y weight upon molecular weight, right? Therefore we can write it as PV equals to given weight upon molecular weight WYM RT, right? Now from the equation we can deduce that pressure equals to 1 atm. In the question it is given, right? It is given that pressure equals to 1 atm, and what we have is uh, volume volume is given as 1 liter, and we have temperature is equals to 127 degree Celsius, 127 degrees Celsius. It is equals to 400 Kelvin, right? If we add 273 K to it, and we have value of W given. W as 2.8 gram in the question. These are the given data we have, right? Therefore, putting these value in the equation. So if we put this value in PV equals to nRT, so we get P equals to 1, V equals to 1, that is equals to 2.8 divided by M, and we have R equals to 0.0821, and temperature is 400, right? So into 400. So therefore if we calculate from here, the M comes is equals to 91.952 gram per mole, or you can say equivalent to 92 gram per mole, right? So this is the value of molecular mass from here. Now we know that atomic weight of carbon is 12, and for hydrogen it is 1, right? So if we write for carbon it is 12, right, and for hydrogen it is 1. This is molecular weight. Now therefore we can write the equation for both of them, right? So the equation will be 12x, let's say, plus of y for hydrogen, as Cx plus CxHy we have taken, right? And this is equals to total mass, right, that is 92. Okay, so this defines the value of x and y will define how much amount of carbon and hydrogen we have, right? So moving ahead, that now according to question, hydrocarbon contains 10.5 gram of carbon per gram of hydrogen, right? Therefore we can write 12x divided by y, and this is equals to 10.5, right? Now solving this equation we get that x equals to, we have two equation right here. First one is, this is second one, and this is first one, right? When we solve this, what we get is that value of x is equals to 7 and value of y is equals to 8, right? Therefore the formula for hydrocarbon that comes out right from here is that we have taken Cx and Hy, putting the value right here. So the formula will be C7H8. Right, so this is our required answer for the question. Thank you.
Hello everyone. The question is 3.7 gram of a gas at 25 degrees Celsius occupies the same volume as 0.184 gram of hydrogen at 17 degrees Celsius at same pressure. So we have to calculate the molecular mass of the gas. So given in the question is the weight of gas equals to, which can be taken as W1, which is written as 3.7 gram. Weight of hydrogen gas equals to W2, which is 0.184 gram, and temperature of gas as temperature of gas, let us take this as T1, which is equals to 298 Kelvin. Always remember to convert degree Celsius into 29 degree Kelvin. We have to add it to, since it is given 25 degrees Celsius, it can be 25 plus 273 K, which comes out to be 298 Kelvin. So temperature of hydrogen gas, which we take as T2, is given as 17 degrees Celsius, which is 290 Kelvin. And we know that molecular weight of hydrogen is 2, and we have to calculate the molecular weight of gas, which is not known. So, as given in the question, we can see that the pressure is constant. So, and volume is also constant, as written here. Same volume. Volume and pressure are same. That means we can write it as P and V are constant. So, in ideal gas equation, which is PV is equals to nRT, which comes out to be pressure constant and volume constant, so, and R constant, so NT is equals to constant. So we can write it as N1 T1 is equals to N2 T2. Now, as we know, number of moles is equals to given mass upon molecular weight or molar mass. So we can write it as W1 upon M1 into T1 equals to W2 upon M2 into T2. So from here we can put the values, which is 3.7 gram of gas upon M1 into temperature of gas, which was 298 Kelvin, equals to W2 of hydrogen gas, which was 0.184 gram upon molecular weight of hydrogen into temperature of hydrogen, which was 290 Kelvin. Now, on solving this, we get M1 equals to 41.33 gram, or it can be written as molar mass of gas is equivalent to 41. Molar mass of gas is equivalent to 41. Thank you.
Hello students, here in this question we need to calculate the density of ammonia at 30 degrees Celsius temperature and 5 atm pressure. Now applying ideal gas equation, that is PV is equals to nRT, and that is number of moles is given by given mass divided by its molecular mass. Okay. Putting this n value in this equation, we have PV is equals to W by M into RT. Now, as we know, density denoted by rho is defined as mass by volume. Mass is represented here by W, divided by volume is represented by V. So, calculating W by V value from this equation, we have density is equals to W by V is equals to P into molecular mass divided by RT. Okay, so here putting all the values of pressure and temperature, and the molecular mass of ammonia is 17. So rho will be, pressure is given to us 5 atm and molecular weight is 17 for ammonia, and R value is 0.0821, multiply by temperature is 30 degrees Celsius, that is 303 Kelvin, and on solving this equation we have value 3.42 gram per liter. So density of ammonia at 30 degrees Celsius and 5 atm pressure will be 3.42 gram per liter.